Good afternoon, everyone. Thank you for registering for this afternoon's ucisa Enterprise Architecture Community of Practice webinar. I'm Lex Wilkinson, the chair of the COP group, but I'm going to be handing over to Graham Snow and David Gee. The session is being recorded today and we'll make the link available afterwards. And the subject of the webinar today is a living blueprint of your university. So over to you, Graham and Dave.
We're just going to go through a journey
Graham,
we've had.
Graham, sorry, I think you're on mute there. I've just unmuted you, so you might need to just track back there a second.
Hello, I'm David G.
Hello, I'm Graham Snow.
That should be so you can tell the difference between the two of us. We're basically going to go through a journey we've had over the last year or so and show you what we've been up to. So this is what we call a living blueprint of it's actually of our institution's capabilities and technologies. And really, the whole escapade started with two problems we had, which kind of culminated in a solution that we needed to work out. The first one, as you can see, we had a slight problem with one of our SANs, which meant that we had a very large set of disk drives that we actually didn't know what they were connected to, which was very much on its last legs. And so the question came out is, well, what are these things connected to? Can you please tell us if this thing does go bang at Christmas, what goes? To which we went around and went, yes, I think we can get this, but we've got to go through everybody. And there was a lot of discussion. And as you can imagine, at Christmas time, panic. The other question that we got asked is, which no doubt has been asked quite a lot of IT institutions in HE, is, well, what does your IT department do for the university? And I think that we've seen quite a lot of people ask these questions. And my answer is, well, name a process that the university does that doesn't involve IT. Didn't kind of go down very well. So we thought, well, we better look at this from both the technical side and the business side and work out what do we have and how can we explain it. In this, we were also asked lots of other questions. Think looking at these, no doubt quite a lot of you have seen these questions asked, and we were constantly asked questions like this, and it was, well, is there an answer? I sat back and thought and said, well, okay, there is. Why don't we go away and model absolutely everything? And so we did. I've got a background in dot-coms, and the dot-coms approach to this was quite simple. Their approach to the whole world was you build a website, lots of money turns up and your stock price goes up. Applying this to HE didn't quite work as the approach of, well, can we throw money at the problem, wasn't perceived to be an appropriate solution to the situation. So we really needed a slightly different approach. And so we looked at what we've got. And what we've got is we've got a lot of knowledge and information, a huge amount of data and systems. And we also have access to a lot of open source software. The thing we also had, which was an issue, is huge amounts of documentation in old formats that's completely out of date. So if anybody remembers WordStar documents and things of that ilk, we've quite a lot of that. For me, that really wasn't a solution. It's, well, what can we do? Let's put all these things together and have something that's living and not live off the parchment that's on the discs. Why don't we try and build a model of the whole of the institution that is living and works? So we sat and contemplated, we looked at quite a few of the ITIL and TOGAF models and thought, okay, we can do this and we can do it formally, but we've got an instant problem that we need fixing. So what we did was we sat and worked out something that we could actually construct relatively quickly to tie to model a university. So if you look at the slide there at the dream is to model absolutely everything, and we go from the technology all the way to the business end. The the on the technology side, you see we have we look at servers and server farms. In the middle, of course, we have the data and the data sets, which are very important, and then there's the application layer. At the other end, which we were very interested in, we have the business side of the world, which we have business processes and services. And one of the important things which glued our world together was actually the ucisa capability model, which actually connected the whole of our institution to the strategy. And if you remember, one of my first questions was, what does IT do for the university? Which actually was probably more like, what does IT do to support the university strategy? We then used the ucisa capability model to actually glue all these segments together. Here's an example we have here. So we can either start at the top or the bottom. So for our university education strategy, well, that links to the student enrollment capability in this example, which then is services the admissions, which of course leads to enrollment. Underpinning all of that, we have a set of applications, data and technologies. One of the issues of modeling absolutely everything is you can't do it all by hand. So one of the things we did was to actually go around all our systems and pull in the data as much as we could. If you look on here, we found it was very easy to pull in the data from the technology and data side and actually go through varying reports to find out what applications we'd purchased and what we had. With that, it means that at the bottom part of your model, you're actually starting with something that you can connect to something else. vSphere, understanding how vSphere catalogs works was actually relatively simple and filled all our technology side very quickly. We also were able to analyze all our Oracle and SQL Server databases to pull all their catalogs in to see how the data flowed. The other thing we have as well is quite a large systems monitoring system. So as well as with this, we actually connected our monitoring systems to this as well, which is quite good because they actually can pull in data flows, applications, and monitor how the world works across the business. The other thing we had as well at the other end is university strategy and also a large set of KPIs, which we can glue together. And again, the other thing that we used on this model was the ucisa capability model to glue the education strategy then to the next stages. Where it glues, we will discuss later. The tool we used was a system called ITOP, which actually is a ITIL system, which we customized and built our model on the top of it. Oh, excuse me. I'll now hand over to Graham, who can show you how this actually shows itself in the real world rather than on a piece of theory and slides.
Thank you, Dave. As Dave's mentioned, what we've really done here is we've tried to model everything. What we've done is we've very loosely followed the TOGAF framework. What we've tried to do is actually separate what we've built away from any framework so that it can actually be implemented in our organization or potentially in any other organization if anyone wants to get involved with this project with us. So it can be implemented in the way that works for you. Effectively, what ITOP does is it's a system that allows you to define objects and define relationships between those objects and then pull data in. As I say, we have built our own layer on top, but it's largely, as we'll show you in a minute, structured around these 4 layers: technology, data, application, and business. And what's really interesting about it is you can actually start from any one of those points. So you can say, tell me something about our data, or tell me something about our business processes. And then you can either look up or down the chain, depending on which direction you want to go. So looking at the model we've got here, I could say, tell me about our student system, and then tell me all the business processes that flows from it. Or I can go the other way and I can say, let's take the ucisa capability of student enrollment, and let's look down and see which technology underpins that. So we can stand at any one of these objects or any one of these points along the chain and look in either direction. But as Dave says, the really key point of this is we wanted to get away from documenting systems, because the problem with documents is they go out of date really quickly. 6 months, 12 months later, your document doesn't make sense. You've got staff dedicating time to have to write this stuff up. So by pulling that data in live, at least half of this chain is documented automatically. So we don't have to get staff to do that. Well, obviously we've got to do some work on documenting the top levels, but everything below, well, our systems can already tell us what they do. So in terms of demonstration, stand by, because hopefully this is going to work. What we have got is some slides which will show you some of the graphing capability that we've built. So if this demonstration does fall apart, we're going to run it on our dev system. If it does fall apart, we can fall back to that. I may at some point jump into some of the slides, because they can also show you in a bit more detail some of the things that we're trying to elaborate on. So I'm going to pull the system in to show you. This is our development system blueprint. Now, hopefully what you picked up through the slides is the fact that we've color-coded each of our layers. So at the top here, you have our business layer in purple, our application layer in yellow. As I say, that we started from the point of using the TOGAF framework. We have diverged from that a bit, so we've pulled all of our software, all of our applications into the application layer as opposed to just the business logic, and that's because of a particular way that we worked. Our data layer here in the green, so all of our tables, our views, and individual data elements. And I'm going to come back to talk about some of the really interesting stuff that we're now building with that at the moment. And then our technology layer, so both virtual and physical pieces of hardware, but even some of the things that we're looking around modeling, like card readers in the bottom left there, multifunctional devices. Now, this is our development system, so we don't have all of our data in here. This is just some test data. But you can see in the live environment, we're working with over 500 virtual machines. So we can start to answer some really interesting questions. So, well, what are all those virtual machines? Because of the fact we're pulling the data in, we actually know how many we've got. Now, as we start to join things up, we can say, well, 50%, 75% of our servers are joined to an application or a business process along the way. So we know what they do. Then we can start to audit those and say, well, what do the rest actually do? Now, that's all well and good looking at this. We can open up an individual object and see. So these are examples of the 70 applications that we have in our application portfolio on here. So for example, our EDRMS, our document management system, our Dynamics 365 CRM system. And if we have a look at one of these, we can actually see some of the information. Now, some of this is pulled in automatically, some of it manually. So we can see the address of our system. We can start to look at objects that it's joined to. So this particular system has 2 modules that we're using. We can look upwards and see some of the business processes that it supports. And also interestingly, we can have a look at some of the live data. So this is being pulled out of our Nagios monitoring system. So we can actually see live the availability of that particular application, but see it in context in relation to what it's actually being used for. And that's particularly powerful because one of the things that we found is a lot of our operational teams are very aware of whether systems are up and down, up or down, but what they don't know is what those systems are being used for or who the stakeholders are. So one of the things we started to do is we now have a stakeholder tab on here, and against that we can map a team, an individual, a department, a strategic business unit, or a stakeholder role. And a role can be anything from this is the group of system administrators to this is a group of end users, this is the project team. Effectively, because of the flexibility of the system, we can define it in any structure that we want to. But what it allows us to do is to start mapping groups of people against business processes, against applications. And from that, we can then start to think about, firstly, notifying those people if there's a problem with the system, but even hopefully moving into the next stage of doing automatic generation of those. What it also allows us to do is assign ownership to these objects. So we can put ownership against business processes, ownership against applications, and ownership against data. So I'm going to take a look at one of our servers for a minute, just to show you an example of some of the other information we get. If I can find it. I can't find the particular example I was looking for. Just bear with me a moment. In true Blue Peter style. So one of our servers, now again, if we look at the live status of this, we can actually see that it's down, but one of the things we're now doing with servers is we're actually pulling in the performance information as well. So we are starting to do some work now on, obviously we can tell there's some problems with this server, but what we would like to do is start building in some information around the fact that we've reached the warning and critical levels. So by knowing the server's down, we can actually see which one of these things in particular is causing the problem, and then we can follow the chain back upwards to see what it's impacting on. Now the really interesting thing is where we actually start to look at those chains. So the thing that we find most powerful in this is the graphing capability. If I find our student system, I should be able to show you that. So you've obviously seen this screen before. What I haven't shown you is these tabs here, these options. So we have the ability now to define two kinds of relationships, and we're actually considering extending this to include more relationships as we go forwards. The first one is impact and dependency, and that's really key to our operational processes. So we can say this student system depends on what technology underpins it, or going in the other direction, what does it impact on? So I'll show you the dependency first. Sorry, I should say before I move on, the other thing is data flow. So we're now looking at modeling automatic data flow between systems. So let's have a look at the dependency. So this is going to take just a few seconds to expand. And then you see a fairly complicated graph. What we can tell straight away from looking at this is we can see some of the colors. So on the right hand side, you'll see a number of yellow objects. There are applications or modules. In the middle, you'll see green stuff, green objects. That's our data. So what we're looking at there is a number of tables, schemas, and views which support the application. And then all the way over to the left hand side, we can see our Oracle rack and the two blue physical servers that underpin that. We can zoom in and out of this, so we can go in a bit closer, have a look at particular components. What you'll see here as I zoom in is that the student system has 8 modules, and that's actually collapsed it down to try and reduce the amount of information we're seeing on the screen. Down here we can see we've got 6 web servers, I believe they are. So I can actually expand this and redraw the graph to see everything. What I'm going to get as I do this is a lot of information, and I'll show you how we can filter it for context. So we've got more on that graph now. What I can actually do at this point is say, well, these are the things that I'm interested in. So maybe all I want to know about is the application and what data it's taking. So I'm going to have a look at the application, the schema, the table, and the views, which support our student system. So that graph's just going to refresh. Any second now. Always when you do a demo. That's not quite happened there. Oh, didn't take the technology layer out. There we go. So now what we should be seeing is just the student system and the green data layer. So we can filter this down as much as we want. Maybe we just want to know what the underlying tables are. So now I've just got the application and the table. And if I refresh this again, we can see these are the core tables. We haven't mapped every table. We've made a decision as to what we think is the stuff that we're interested in. So these are just the core tables and the schemas that those tables come from. which support our student system, be it because of they are directly underneath the system, or these are tables that might be feeding data into the student record system. Now we can also go from here, go the other way. So if I right click on this, I can actually see the impact. And I think as I do this that we haven't mapped out the student system on the development system. So I'm just going to jump over and show you another one. So let's have a look at our research information system on here. So our core system for managing our researchers and responding to the research excellence framework. So that's looking downwards, looking at the technology that underpins it. If I right click and go upwards, we can now see the I'm going to expand this to show you. We can see the business process, the sub processes, business processes. So the first layer is sub processes, second layer is business processes, the third layer is the ucisa capability model. That's level 2 of the model. And then we can actually see this coming up to that target is a strategic objective, which forms part of the research strategy, which is part of our strategic plan. As you can see, just above that, you can actually follow the capabilities all the way up into the capability model as well. So we can include business models in here, whether it's the ucisa capability model, our strategic operating model, or any of our other strategic plans. And again, for many of these objects, we can at any point go upwards or downwards. So for example, I might say our research strategy, to answer Dave's question from earlier, what technology underpins our research strategy? So I'm going to see the dependencies from here. Obviously getting quite a lot of information there. Well, actually, I'm only really interested in the applications. So let's stop at the application point. And I'm just going to expand this to 8 so we can see all the information. So as I do this now, you should be able to see from the research strategy downwards, it's actually underpinned by 3 core systems. So our research student management system, our research information system, and our research archive system. Of course, what I could have done is followed that all the way down to the technology layer. But one of the really valuable things about this is being able to filter the graph to present the information that you want to give to the particular audience that you're speaking to when you do this. Now, obviously, I'm generating a lot of graphs here. What I can also do is export this as a PDF. So if I do need to present this in a particular report, or if I'm going to a meeting and I want to hand it out as a handout for people to take away, then the PDF failed to open. I'm not quite sure what that was. Oh, this is PDF generation doesn't work on our dev system. If anyone does want to see that before the end, I can show those PDFs, but it looks very similar to this, except you get a key with explaining what all the objects are. Now, one of the things we haven't talked about is too much is our how we're pulling the data in from Nagios. So as we look at these individual objects here, what you may not realize is that those black lines represent the fact that actually those systems are live at the moment. So when we look further down the chain towards some of our technology, because we're actually pulling in live data from our monitoring system, as we show the graphs, if anything's down, these lines go red. So a line from one object to another. Yeah, we've got a really good graph that we can example we can show of this on our slides. Thank you, Dave, for pointing that out. Here we've got a slide showing business impact. So this is one we captured earlier in the year when one of our particular servers went down. That server was underpinning part of our Oracle rack. What's really interesting about it is that we hadn't realized at the time that that particular server underpinned such a wide variety of systems. So looking as we go across, that Oracle rack had dependent on it Alteryx, which does a lot of our data flows, BI Publisher, Jira, which we use for managing IT projects, and Confluence, which we use for currently use for some of our operational documentation. So that particular server had impact on business processes as wide-reaching as student debt management, clearing, issue and requirements management, and some of our DevOps knowledge sharing. So a really wide-ranging impact for one particular piece of kit going down. We can just skip through some of these and just show you another couple of examples of that. This harks back to Dave's original question about the EVA. So our SAN, when we ran into a problem. this is an example of being able to map applications all the way down to the storage layer. So luckily, we'd moved by the time we sort of made some progress with Blueprint. We'd moved a lot of our stuff off that EVA. We are now operating on different infrastructure. But at the time that I came to do a screenshot of this for the presentation we gave at the ucisa Leadership Conference, actually coincidentally, we're having some problems with one of our domain controllers. So that's quite a lovely example there of, in that screenshot of the domain controller up at the top having an impact on a number of different applications. The other sort of things we've been using this for is change planning. So our student system has 97 different integrations to it. So we can actually have a look at all of those connections coming in and out. So the slightly greyish symbol with a cog on is an integration. That can be an API, it can be a PL SQL package, it can be an integration built directly into that system. So if it's got some kind of integration module in it, but we can reflect all of that within Blueprint, and we can show joins from one application to another and where the data is flowing into that. Data flow is the thing I get particularly excited about with this system. So I just want to show you this example. This is coming out in the next release of Blueprint. So this is something we're particularly proud of at the moment that we spent quite a long time working on. Dave and myself largely lead our data management group here at the university. So we spend a lot of time discussing where data comes from, where it goes to, whether it's being handled appropriately. One of the challenges we had is that we do, at the moment, quite a lot of point-to-point integrations. We're moving more to using Alteryx, but we had some problems around change control for data flow. And so rather than relying on documents that tell us what was agreed a year ago via a committee, we actually wanted to know what's happening in real time. Has anyone changed it? We particularly run into some problems with some of the systems we manage where one project or one community of people have decided to go and make a change to some of the data they're using without understanding the impact that that data flows to other systems. So what we've actually done, as I say, over the last sort of 3 to 4 months is we've worked out how to model in real time all of our data flows. So this example here that I'm showing you is being pulled directly out of our Oracle systems. This is still in development at the moment. This hasn't quite gone live yet. But we are able to say, taking an individual data element, where does it come from, and tell us all the place it's going to. So as an example, we've just run this recently against one of the core tables in our system, in our systems, which is the person table within our student system. So that table which contains primarily the key information about an individual, mostly students, of course. And from there, we can determine that the data in that table goes off to 9,000 different places. So those individual data elements are shared in 9,000 different ways. So running through this example I've got on the screen here to explain a bit more context of what I'm talking about. On the left, we have our student record system in yellow. And we can say from there, draw me the data flow. The first object we reach is an object that says that the student record system is the authority for student data. It is the master source for student data. And within that, we've defined 3 data sets. So we have a data set containing students' core details, so their name, their ID, their date of birth. We have a data set of course fee data, so courses and the costs of being on those courses, and a data set of module details. There are obviously other ones. I've kept this simple for the purposes of this screenshot. Now, within our student core details, we've got a surname, a middle name, and a first name. We also have a student ID, and you'll notice that that student ID actually sits within all of the core the data sets because it allows us to uniquely identify a student. Now, as we move further along, you'll then see that the surname, middle name, and first name are being joined together to become a full name. Now, that's something we're actually pulling live out of our Oracle databases to understand that. And what that can tell us is not just that data, those 3 data elements have been merged into one, but it can tell us any of the transformations that have taken place. So if it's a student number, we can tell whether we've padded it to 8 digits. If it's a surname, we can tell if we've uppercased it, lowercased it, done any cap on it. We can tell if something has been decoded. we can tell if two fields have been joined together. So that second slightly lighter green object is what we call a derived data element, and it contains within it any transformations that have taken place. What you see sitting between the first set of data elements and the derived data element is a yellow object, which we call a SID. It's our system integration document. Pardon? Oh, sorry, purple. I'm slightly colorblind and not quite thinking about what I'm saying there. So the purple object is our system integration document. That is what we call the data sharing authority. So that can represent either an internal document that says that data can flow from one place to another, or it can represent a data sharing agreement if you're sending data outside of the organization or bringing data in. At the moment, we are mostly doing that with Word documents. What we now want to do is move this to a more electronic process, because when we've got the document signed off, as we do through our data management group, in future we'll be able to model in real time whether the data being shared conforms to the document or the agreement that was signed off at committee level. Also, we can tell whether one's missing. So what's interesting is you look up at the top, the student accommodation SID says that first name, middle name, and surname can be taken together, merged into a full name, and passed over to the accommodation system. Without that, if we drew this graph, we'd be able to see still that the data was flowing across, but we would be able to see that there was no authority for that data to be shared. So we're able to continue to watch that in real time to make sure that what we are doing conforms to what was agreed. We've shown you that example already. That's our research strategy flowing downwards. We've shown you change planning and operational monitoring. And one of Dave's favourite slides is this one, which is a bit nerdy, really. But what it tells us is about the shape of complexity. So on the left, we have our check-in system. What you should be able to tell fairly quickly from looking at it is it is wider than the graph on the right, but not taller. Whereas the graph on the right is quite tall, but not particularly wide. Well, actually, what this tells us is about where the complexity lies in these systems. So the graph on the left, our check-in system, has a large number of hops in it from a technology point of view between the different components. So that is technically complex, i.e. The technology underpinning it is complex. On the right, because it's fairly thin, there isn't much technology involved. Actually, what we see is a lot of business processes. So the reason that graph is so tall is because we're doing the same thing, so the same kind of integration, but we're doing it 78 times between that particular graph just shows data flowing into our finance system. So it's got some quite interesting things just in terms of being able to explain complexity to people. The point Dave always makes about this is we get asked, why do IT make this so complicated? Why do you always make this such a challenge? And using some of these graphs, we're able to show, well, actually, we don't. So the reason this is so complicated is because we have 78 different business processes that cause data to need to be taken into our finance system. So which one of those 78 business processes would you like us to stop doing? Should we stop taking in student fees or stop taking in money through our bus company? And so actually it helps us to explain what is really going on with our systems. Now I'm actually going to jump in and do a quick demo of that because I think that's quite interesting as an example. So if we find our finance system, Tech 1, and I'm just going to look at what Tech 1 depends on. That's a fairly simple graph at the moment. You'll see, 74 integrations we've got on there, slightly different from our production system. But you see 74, it's compressed it. So if I change that up now and say, show me everything, you'll see instantly we get that complicated graph that was on the presentation before. Not particularly useful. But if I change this now and say, change the grouping threshold down to 20, hopefully that should be about the right level for what I'm looking for. It is. I'm going to just drop that down a little bit more actually. There we go, perfect. I'm going to do actually just one more down to 5. Not quite. I knew I was going to get it. There we go. So now we've got what we've got is context. So on the right, you can see our finance system, as we've already explained. But within finance, we've got these 6 modules or contexts, as we call them. Sometimes a system doesn't have modules, strictly speaking, in the technical sense, but it does have areas of the system that we're interested in. So we've split our finance system into 6 contexts. So procurement, the general ledger, and accounts payable. And we can actually see the number of integrations going to it into each. So straight away we can see our general ledger that takes in 28 integrations, which are coming from 51 different data files which exist on a particular server. So again, it allows us to understand where is the complexity, where is the amount, the most work going on, what are the things we need to think about. Now, in terms of our integrations, one of the other things we've done, just going to drop this down so I can get into one of them, is we've now also started to think about scheduling. So because we can pull information live out of our Alteryx system, because we can pull it live out of our database management system, we can actually put a schedule against an individual integration to say when does it run. So this particular integration here, which is pulling in reminders for receipts, it's a ETL process that's part of the application. We can actually set against it what day of the weeks does it run, which hours and minutes. We're working on at the moment pulling that data in because this is part of our development that's about to go live. And what we can then do is build up a calendar of the week so we can see when are our data feeds running, which is really great when we combine that with our monitoring information, because we're able to say, well, hang on, this particular server went down on a Sunday night. What actually happens on that Sunday night? Well, actually, all of our, or some of our data feeds into our finance system runs, so we can work out what was affected. The other thing we can do is better planning. So we can say, we are planning to take this server down for a period of time to do some upgrades on it. So we can actually see when is the best time to do that. We can also look at things like our backup schedule. So are we running our backups at a time that clashes with when our data feeds are happening? And because we've pulled all this data into one place, which is really the key point here, is that Blueprint gives us the ability to aggregate lots of useful data together. We're able to start to think about how these things work, where it overlaps. There's and think about stakeholders involved. So a server's gone down. Who needs to be involved? Daniel looks after that particular system. He's off on a Monday. The server went down on a Sunday night. It affected a particular part of the system or a particular function. What do we do? Also, on the inverse of that, because we know that we're about to do some change on a system, we can start to think about our stakeholders and how it's going to work. So, for example, we're now looking at pulling in annual leave calendars from HR. So we can think about if we've got a particular piece of change coming, does it affect the data feeds? Does it affect the backups? Does it affect what staff are available at the time? Just thinking about other things that we were going to show you on the system. Dave, another development that's coming out in our next release. Dave is madly waving at something on the screen to remind me what we wanted to show you. One of the things we found about the capability model is obviously, for hopefully you've all seen it. I'm just going to pull the capability model up on the screen. So this thing, of course, this wonderful thing that's helped us to structure our university and join our strategy to the business process. Very good as a picture for explaining things, but obviously what we want is we want data. We want something we can play with. So we built it. So again, bear in mind this is in development at the moment, so it's not quite as pretty as we'd like it to be, but we're getting there. So this is an interactive HTML5 and jQuery version of the ucisa model. I'm going to hand over to Dave because this is his baby, so he should be able to explain more about this.
So we had the problem of actually gluing applications and services together, and it's how you do it from a list. And one of the great things with the capability model is very, very visual, and you can actually sit and point and click things. So what we decided to do is build a JSON version of it, and we have a drop down of fields, and then we click things about them. So we have a selection of different colors. If I can make it the authoritative source, so in this case, I'm going for student names, and we're saying that those elements are the student names. And then I can say add items and say that what's affected by them as well by turning them into green. So I'm having problems looking at the diagram as we speak. If we can zoom that in or find something appropriate. There we go. My eyesight isn't as good as it used to be. So we can then say, right, for student names, where do they go? Oh, they go into those elements, and actually that from careers and employment then goes into housing advice, which would be indirectly. So it meant if we did lose the authoritative sources, we can actually map the directly affected ones and the indirectly affected ones. And so we've been using this tool basically to populate Blueprint with a capability model. And it's, I tell you, from actually going from trying to do it by spreadsheets, it really has been a great tool just to be able to point and click.
One of the other things we've been thinking about is about visualization. So a really interesting thing we've seen in our organization over the last sort of year or two is the fact that things that Dave and myself have been saying for years and showing in spreadsheets are never really believed. But the minute we put the same data in Tableau, suddenly everybody buys into it. So we've had a bit of shift in thinking in terms of trying to be more visual in the way we present things. And we're trying to apply this now to Blueprint as well. So one of the things that we get is that sometimes our graphs are a little bit overly complicated. So what we're going to do is we are using this JSON model to push data into Blueprint. So it's about allowing people to do data entry, but we're also going to use it to push it out as well. So we can present for an individual area the part of the capability model that they're interested in, and then show the applications against that capability or show the data feeds against that capability. So we can pull data out of Blueprint and present it in any of these boxes so that people can see the context that's relevant to them at the time. Now, so Dave wants to add a quick point.
So with it, some of the issues we have, and other people have too, is the fact that some of the areas think in silos, and so we can actually use this to say, right, you're changing this piece of software. Do you realize it directly affects this system and indirectly affects these? So when you change your application, you need to inform these stakeholders and also think of their needs.
Thanks, Dave. So I think when we've talked to a few people about this, one of the questions obviously that we get is, it's great that you're pulling this data in live, which we think has been really key, is to get away from doing stuff on paper, stuff on out of date electronic documents. But obviously the other question is, well, how are you doing the top stuff? So how are you mapping out the business process side? If I jump back to my presentation for a minute. So obviously, sort of halfway down the chain, we're pulling a lot of live data in, but at the top end, a lot of this can be manual work. Now, one of the advantages of iTop, one of the reasons we chose it, is you can pull in data from any source. So that can be a system of any kind, a database, but you can even just load in data from spreadsheets. So anywhere we've been able to get our hands on any KPIs, any business process lists. We've recently pulled in our service catalog, which was previously in a spreadsheet. Then it's really helpful to pull that data in, because just the act of bringing it into Blueprint makes it more alive, especially once you've joined some of these things up, because we can show that the stuff underneath is living, and that keeps rolling all the time. Okay, so that data is living, it rolls all the time, but where we can see when the bottom stuff changes, it normally indicates we need to change some stuff at the top. Obviously, there is a challenge in getting the resources to do some of this top level mapping, but what we've really been able to show is that we can save time by doing the automatic modeling of data in the bottom layers, which frees up time to do some more of the mapping at the top. The other really key thing we've done is try to pilot this in areas. So we've been looking for communities within the university who are open to new ideas, who are looking to innovate, who are looking to particularly manage things better. So the two real champions for this were our research area. Research was good because it was particularly contained. So unlike things like student data and student systems, there weren't as many integrations into research. So we were able to do that as a fairly nice, simple, contained exercise. But we have also tackled registry. Registry were really interested in this because they have to manage processes and data in a very, very difficult regulatory environment. So I think they've got something like 38 different returns they have to do of data to HISA. So understanding their processes and the data flows was really key to them. And that's really been the driver, is trying to show people the sort of the amazing things we can do by modeling this live that will help them, as the carrot to encourage them to try and get more of their information in this. I have been doing quite a lot of work of just going around talking to people to find out what they've got, to show them that the documentation that they've got isn't quite up to scratch, and we can actually model some of this stuff in a much better way, and keep it up to date in a better way. Our next big step really is to try and get as many of the stakeholders on this as possible, because then we can start to think about doing some auditing, some governance type activities to say, well, actually, you haven't updated these objects in the last 12 months. Can you log in and have a look and make sure that they still reflect the real world? Because of the fact that we've got live data, we can automate some of the activities that we might have to do manually previously. I think that pretty much brings us to the end of the presentation. We've, as you can see, this system does a lot. So we're modeling effectively everything, and we keep adding new things to this all the time because it's very easily extensible. We can keep adding new objects and defining new relationships, which means it does keep growing, and it is a bit of a beast, which does cause us a bit of a problem when we come to talk about it, because we need to know what you're interested in order to know what to show you. But we would be more than welcome to kind of do more detailed demonstrations of the system and how it actually works. Talk to people about any interest they have in that, and if anyone wants to get involved in this, we would be very open to partners or whatever kind of arrangement to kind of get other people involved in this, because we think, from what we've seen from talking to other communities, we think the fact that we're doing this in a live way is fairly innovative. We haven't really come across too many other organizations doing this kind of thing at the moment. If anyone is, please tell us, because it might be that they've got something better than what we've built ourselves. Okay, so is there any final questions that anyone wants to post to us? You can get in touch with us via our email address, blueprintu@hearts. That's a
We've
bit
got
about what's coming up.
Hi, we've got a couple of questions coming on the chat channel. First one is it just the two of you developing the system?
We're sharing a headset between us at the moment, so Dave didn't catch that question. Just to relay it, the question was: is it just the two of us developing it? So technically, yes. As you say, we've built this on top of an open source system, an existing ITIL system called ITOP. So we haven't had to develop an entire system from scratch. ITOP is an ITIL system, and what we wanted was an enterprise architecture modeling system. So we've built our own module for ITOP over the last 12 months. Yes, it is just the two of us effectively within the organization. It's been
Steal resources from
we do, as Dave just said, we do beg, borrow and steal people from elsewhere. The ITOP itself has been, I don't know, sort of 2 days a week to 3 days a week of my time over the last 12 months, with Dave probably doing a day to 2 days a week, handling a lot of the kind of the monitoring side, getting the data out of other systems. But yeah, effectively just us.
And so you just covered one of the next questions on how long it's taken to develop. It's been approximately 12 months.
Yeah, about 12 months. I would say that is because it's been very much an agile project, and I use the word agile very loosely here, because it was just Dave and myself, so we're not talking particularly detailed methodologies. What we've effectively done is built this iteratively. It's been built as a bit of an evolution. So we've tried it and tested it as we've gone along. We've discovered sometimes that the model doesn't work. So what we thought was the relationship between different things turned out to actually not work in practice. So we have ended up redeveloping things that we've already built, and going back to the drawing board, which is part of why it's taken us how long it's taken us to get where we are. Also, we do have day jobs.
One more question here. ITOP, what else are you using ITOP for in the university?
We're actually not at the
other
moment,
functions?
interestingly enough. So ITOP is a change management system. It's a help desk system. So it has a portal for tickets in there. and I'm trying to think. It's got a number of different modules that I'm struggling to think off the top of my head at the moment. I'm just going to pull the system up because it has got a list down the side. Sorry, change management, service management, and help desk ticket system. We already had those. The reason we adopted this is because of the fact its ability to very quickly and easily model objects and their relationships between them. So Dave had come across this previously when our organization went out to look for a new help desk system, and they didn't choose this in the end. They went with something else. But as this continues to grow, we may look to bring more things back onto the system.
Okay, thank you. I think that's it for questions at the minute. But I'm sure people can contact you directly as well if they want to follow that
We'd
up
love to
further.
hear from people, get their feedback, even if there's things about it you think that doesn't work, or you think we're mad. We've kind of gone off and built this as a bit of a sort of a fun project for ourselves that's turned into something actually really critical. So if anyone's got any feedback at all, we'd love to hear from you. You can reach out to us directly, or there is the email address on the screen there if you want to send any feedback, but please do.
One final question's come in. I think we probably covered it earlier on. How many of the data interfaces are captured?
How many?
Yeah.
I don't know. We never looked at the total. So obviously some of them we can pull out live from our databases. How many interfaces in total? So just on our development system there, we got 244. Production has more than that. I wouldn't like to show the production system for obvious reasons, but so Dave's whispering in my ear to say it's about 300 on production.
Right.
So as I say, where we can find them, where we've got them in Alteryx or where we've got them in our database management systems, we can actually pull those out live. We have had to document some of them manually. So sort of APIs and web services here and there that aren't held or managed in a central system. We have had to go and have do some kind of workflow mapping with people. But the interesting thing is that sometimes Blueprint points as to where there's a gap. So the fact that we can see there's a server there but nothing on it, the fact that we're running OpenNMS to discover open ports on the network tells us that there's something, and it allows us to go out and say, well, hang on, we found that you're probably doing an interface here. Can you tell us what it is?
Right. Thank you. There's a couple more questions come in quickly. I'm just trying to access them. One of them I think was, what are your plans for the module? Is it something that you're looking to share or make available?
We got asked this question at the ucisa Leadership Conference, which is what are your plans? Are you going to sell this or what? To be honest, when we built this as a thing for myself and Dave initially within our own team to answer questions that were being posed to us. And we soon discovered that there was a lot more interest in that. So every time we went and spoke to a different group of people, they said, oh, can we use it for this? Can we use it for that? So we've continued to expand it and develop it over the last year to do more than we originally intended. We've had a number of a couple of universities and some other organizations who are interested in kind of taking this further and taking it up themselves. So we are in the process at the moment of discussing what that might be. Some of those, it might be commercial, it might be knowledge transfer type projects. It might just be that the case that we really just want to work with people and say, give it a trial, see how it works for you. If you can kind of get involved and build some parts of this as well, then maybe we can all come together and work on it collaboratively. So we haven't really worked out what those arrangements are yet in terms of people getting involved. It's probably going to depend on what they want to do. If they want to get involved and help us build it, then that's a different scenario to wanting us to deploy it for them and support it for them. But I'd say come and talk to us, come and tell us what your interest is in it, and we can see what we can work out.
Great, and I'm sure that it'd be really good to kind of keep some of the dialogue going on the community practice forum as well, and see what people think
love to.
what you've done. So I think we should draw to a close there. Just a reminder that the session is being recorded, so I will send out a link to that probably early next week. And just really thank you, Graham and David, for the time to share your work. It's been really, really fascinating. So thank you very much for that.
Thank you for having us. Really appreciate it. It's good to talk to people, and hopefully we'll get some interesting feedback and questions from people. So we'd love to talk to you about it.
Pleasure. Thank you. And final word, if anyone else is interested in presenting a future session, please get in touch with me, Lex Wilkinson, and we can have a chat about it. So thank you everyone for attending. I hope you agree that's been really, really interesting.
Thank you very much.
Thanks everyone.